All right, so welcome back. This is lecture 2. Yeah, so this is a revision in trigonometry. Yeah, my name is Hamte. So let's quickly begin. Okay, so the questions that we're going to be answering are from the tutorial sheet. We'll continue from where we ended. We'll continue from where we ended. Then if you have any questions, you want clarification on anything, on any topic in either math, physics, or chemistry, or even biology, feel free to contact me using the lines on the screen. Yeah, so let's quickly start. So we ended on question 4. So today we're starting with question 5. Okay, so question 5 is asking us to find the exact value of each of these trigonometric ratios. So this is something that I believe is going to be easy and simple for us because of question 4. There's a part where I talked about the compound angle formulas. I didn't just write all the 3, I only wrote 2. They're actually supposed to be 6. Yeah, so I think I'll start first by writing all the 6 compound angle formulas. And then if you have anywhere to copy, or if you have a book nearby you, you can just be copying them. All right, so the first one I'll start with the one for sine. So for sine, if you have two angles, let's say A and B. So we say let A and B be any two angles. So the addition of those two angles, to find the sine of the addition of those two angles, or the sum of those two angles. Okay, let me just be writing what I'm saying so that you can get, or you can understand properly. So what I'm trying to say is that for sine, okay, so for sine, when you say sine A plus B, sine A plus B is simply just equal to sine A cos B, sine A cos B, and then plus sine B cos A. So this is how you know how to do this. This is how you know them. So for sine, the sign here in between. If you have a plus there, whatever you're going to have there, whatever you have there is exactly what you're going to have there. So if there's a plus there, it means that you're going to have a plus there as well. So that is how you know the compound angle formula for sine. So if you have a minus there, if for instance you have sine A minus B, so this will be equal to sine A cos B. Then the other thing is that if you have, if you start with A here, if sine is having the angle A, this side sine should come and have the angle B. So if I start with sine A this side, I'm going to have sine B this side. Then if there's cos B here, it means that I'm going to have cos A. Yeah, so that is exactly what you're supposed to do. All right, so these are the two compound angle formulas for sine. And then we can also find what are known as double angle formulas from these same compound angle formulas. But I'll not talk about those because this one is just a question where I just need to write the formulas and show you how to apply them. Otherwise, if you need a lecture where I explain the compound angle formulas step by step and even deriving them, including the double angles and the half angle formulas, you can ask for it. I'll send you the link on WhatsApp, then go through it. Okay, so this is for sine. Let us also look at cos. So we have cos A plus B. So for cos, when you have a plus in between, it means that what you're going to have here will be a minus. So, and for cos, the angles, the angles do not switch. Yeah, let me say the angles do not switch. So we say if we have cos A here, we're going to have cos B there. So this side will have sine A, then sine B. So the only thing that changes for cos is the sign in between. So if you have cos A minus B, the answer becomes cos A cos B. Then here we change the sign, then it becomes plus there. So we have cos, it's supposed to be sine A sine B. Okay. And then the other thing is, the other trig ratio is tan. So when we talk about tan, the trig ratio, the first one is tan A plus B. So tan A plus B is simply just equal to tan A plus tan B then everything divided by 1 minus tan A tan B. And then when we talk about a minus, when you say tan A minus, when you say tan A minus B, okay, let me see if I can write it down. Let me just reduce the font for this. Then for tan, we have tan A minus B. So this will be equal to, on top, we'll still have the same tan A, but the sign in between there will change to be tan A minus tan B. And then everything over 1 plus, even here the sign changes. There was a minus, if you check here, there was a minus, then here we're putting a plus. Then we have tan A, tan B. So that is exactly what you're supposed to do. Okay. So these are the compound angle formulas. These are the formulas that we're going to use to solve these, to find the exact values for these trig ratios. Okay, so let's quickly begin. So the first one is sine 15 degrees. So when you look at 15 degrees is not a special angle. But how do you find the exact angle, the exact answer for such a question? This one is straightforward. You just need to find two special angles that you can add or subtract to get 15. And 15 can be gotten by using 45 degrees and 30 degrees. But if you don't want to use these two special angles, you can also use 60 degrees and 45 degrees. You still get the same answers. So we know to say when you say 45 minus 30, the answer will be 15 degrees. When we say 60 minus 45, the answer will be 15 degrees. So here it's just a matter of getting two special angles, and then those special angles, what you do with them is you subtract them. Yeah. Or we can find two special angles that we can add to get 15. If they are there, you can use them. All right, so let's quickly begin. So now, since we're subtracting, we're saying sine 15 degrees. We're saying sine 15 degrees is just the same as sine. Then in brackets there, we're going to put 45 degrees minus 30 degrees. This is what we're going to put there. So now, remember what I said? If we have sine A minus B, the compound angle formula for this is simply sine A cos B minus sine B cos A. So we can replace the values of A and B to be 45 and 30. Yeah, we can replace 45 and 30 there on A and B. Okay, so let us do the replacing. So we have sine 45 degrees minus 30 degrees. So this one is just going to be equal to, while there's A there, I'm going to put 45. So we say sine 45 degrees cos. While there's B, I'm putting 30, sine 30, I mean cos 30 degrees. Then since there's a minus there, we put a minus in between. So we have sine 30 degrees, and then we have cos 45 degrees. So here is just a matter of working out the special angles. Remember that table I drew for special angles, those that attended the first lesson, or those that watched my video about special angles, how to find how to find the solutions of special angles. Yeah, so if you need that video, I'll put it. Yeah, I'll put it, I think, in the description of this same video. Okay. So this is how you, I mean, sine 45, we said from the table that we drew up, sine 45 is simply just the root of 2 over 2. Then cos 30 is simply just the root of 3 over 2. And we say minus sine 30 is simply just 1 over 2. And then cos 45 is still root 2 over 2. Okay. So this is what you get, and then it's just a matter of simplifying the expression. So the root of 2 times the root of 3, we're getting the root of 6 over 2 times 2, we're getting 4. Then we say minus 1 times the root of 2, simply just the root of 2 over, then 2 times 2, we're getting 4. Okay, so this is the solution. If you want, you can simplify it further as the root of 6 minus root 2, everything over 4. Yeah, so if you want to prove this solution, you can use your calculator, try to find sine 15. You discover that the answer will just be equal to this. Do we have any questions before we proceed to the next one?
So, sir,
Okay.
we're supposed to know this,
The compound
these
formulas.
No, like the way I've put sine 45 and then it's equals to that.
Or
supposed to know
this
them.
part. These.
Yes, yes, yes.
Okay, immediately we're done with this class. Tell me to send you the video where I explained step by step how to master these. They are very simple.
Okay, thank you, sir.
All right. Okay. So we move on to cos 165. So cos 165, we'll do the same. We have to find 2 special angles such that if we add them or subtract, the answer that we're going to get should be 165. So what are these special angles? Okay, so 165, if I subtract, I think, okay, if there's anyone who has found them, let me, also be asking you, which two numbers can we use? Or which two numbers can we add or subtract to get 165? Which two special angles? Hello? Someone to give me two special angles. Remember, the special angles I'm talking about are 0 degrees. We have 30 degrees. We have 45 degrees. We have 60 degrees. We have 90 degrees. Then apart from that, we also have other bigger special angles like, I think we can also talk about 120 because it's
The about 145.
Yeah, even that can work. Yeah, so
Okay.
yeah, but when you use 120 again, it's
Uh-huh.
going to be a bit tricky because you need to consider the quadrant of this angle. So let's try to pick from the numbers that I'm going to write on the screen. So 90, and then we can also get 180 degrees. Then we can also get, what else? We can also get 270 degrees. I'm trying to get some of the angles that are even in the unit circle. Then we can also get 360 degrees. Do we have any two angles that we can add or subtract to get 165 rather, from the angles that I've written on the screen? Okay, it doesn't seem like possible. So it doesn't seem to be possible using these. So now we can employ other special angles like 120 degrees. Yeah, so if we use 120, then we're going to go by the one that you just mentioned, which is 120 plus 45 degrees. So these are the two angles that I'm going to use. Okay, so let us quickly write that by using cos. So we know that cos A plus B, cos A plus B is simply just equal to cos A cos B minus sine A sine B. And then we are getting 165, and so we're adding 120 and 45. So these are the two angles we're adding. So the first one will be cos 120, and then the other one will be sine 45, rather cos 45. Then we say minus sine. Our A in this case is 120. Then our B is simply just 45. So we say another sine 45 this side. So now, what is cos 120? You want to give me the value for cos 120 from the table that I gave you, or from the table of special angles? We never had 120 there, but from what we learned in the last lesson, I think we learned how to find the value for that. Remember what I told you. If you are getting, if you've been given any special angle which has the answer, which, okay, I don't know if I can say which is unknown, but if you want to find, for instance, the cos or the sine of 120, I told you to say you get the special angles which is close to 120. And I told you to say you get angles that are in the line. Maybe you can get 0, but from 0 you can get 180 degrees. both from 180 degrees, you can get 360 degrees. Remember this, I told you in the previous lecture to say, you get one of these three angles and then try to subtract what you've been given and then see the angle, see the angle that you're going to get, the acute angle that you're going to get, which is equivalent to 120. Yeah, so which one is going to give you an acute angle if you subtract 120 from that angle between these? Because when we know to say, when we say 120 minus 0 or 0 minus 120, the angle that we're going to get is not going to be an acute angle. An acute angle is simply just an angle that is less than 90 degrees. So if we say an acute angle, or if we say we need to find a special angle between these three angles that I've written here, such that if you subtract it with what you've been given, the angle that you're going to get should be an acute. So that acute angle will be equivalent to what you have there. So in this case, since 120 is less than 180, or rather, since 120 is less than 180, what you just need to do is to get 180. So you're going to say 180 minus 120. Yeah, so 180 minus 120. So if we had something like 300, if we had 300, we would have gotten, if we had cos 300 here, we would have gotten 360. So that if we subtract 360 minus 300, we're getting 60 degrees. So in this case, we have 180 degrees. We have 120 there. So 120 is less than 180. So we get 180, and then we subtract 120 from 180. So if we subtract 120 from 180, we're getting what? We're getting 60. So this one can also be written as cos 60. So cos 120 can also be written as what? Cos 60 degrees. But when you look at 120, 120 is in the second quadrant, because this one is 90 degrees, this one is 0 degrees, this one is 180 degrees, then this one is 270 degrees. So 120 is between 90 and 180. So 120 is between 90 and 180. So we can find 120 somewhere there. And so we can find 120 somewhere there, which implies that 120, this angle 120 is in the second quadrant. So if it's in the second quadrant and we're dealing with cos, remember, if you're dealing with cos in the second quadrant, we know that it's only sine, which is positive. In the third, it's only tan. In the fourth, it's only cos. Here, all trig ratios are positive. But we're dealing with 120, which is in the second quadrant, and cos is negative in the second quadrant. Only sine is positive in the second. So we add the negative this side, because cos is negative in the second quadrant. And then we also say cos 45. So I'm just trying to write these properly before we start finding their solutions. And then we also have sine 120. So sine 120 is also going to be the same as sine this same 60 degrees, because you also have to subtract 120 from 180. So we're saying sine 60 degrees. But since 120 is in the second quadrant and sine is positive in the second quadrant, so we leave it the way it is. And then we also write sine 45 there. Okay, so do we have any questions first, by the way, before I can proceed from this point? Okay, I think we can proceed. Continue. So cos 60 from the table, cos 60 is 1/2. Then cos 45 is the root of 2/2. Then minus sine 60 is the root of 3/2. And then we have sine 45, which is the root of 2/2. So you need to know these angles in your head. If you can't master them, there's a simplest way to master them. Yeah, so if you need the video, just contact me on WhatsApp. I'll send it to you. All right, so when you multiply these two, we're going to have negative 1 times the root of 2. We're getting negative the root of 2 over 2 times 2, we're getting 4. Then we say minus root 3 times 2 times root 2, you're getting the root of 6. Then everything over 2 times 2, you're getting 4. So you can simply just write this as negative root 2 minus the root of 6 over 4. So this is exactly what you're supposed to do. I've made a mistake, I've deleted everything. Hope you have copied. Okay. So the final solution was then negative of root 2 minus root 6, everything over 4. This was the final solution. Okay, so let's move on to this one. Yeah, so tan 105. So which two special angles can we add or subtract to get 105?
60 and 45.
Pardon?
60 and 45.
Yes, so when you add 60 and 45, we'll get 105. So we're going to say tan, first let's write the formula, which is tan A plus B. So tan A plus B is simply just equal to tan A plus tan B, everything over 1 minus tan A tan B. So this is what you're going to use to find the solution for that. So while there's A, I'm going to put, okay, we said we're going to use 60 and 45 degrees. This is what we're going to use. So while there's A, I'm putting 60. So I'm going to say tan 60 degrees plus tan 45 degrees, and everything over 1 minus tan 60 degrees tan 45 degrees. So tan 60 from the table was the root of 3. Then we say plus tan 45 is 1. Then everything over 1 minus tan 60, which is the root of 3. And then tan 45 is simply just 1. So you simplify this, you're getting the root of 3 plus 1 over 1 minus the root of 3. Yeah, so some lecturers will not allow you to leave your answer in this format. So what you can do is you can rationalize this expression. So what you do is say root 3 plus 1 over 1 minus the root of 3. So we multiply everything by the conjugate of the denominator. So the conjugate of the denominator will be 1 plus the root of 3. You just change the sign in between there. Then even on top, we multiply it with 1 plus the root of 3. So on top, we're going to have root 3 plus 1 squared, because this and that is just the same. So on the denominator, we're having 1 squared minus the root of 3 squared. So on the numerator there, if you want, you can simplify it. You get 3 plus 2 root 3, then plus 1. Everything divided by, have 1 minus 3. So you have 3 plus 1, you're getting 4, plus 2 root 3, everything over negative 2. Yeah, so when you simplify this further, you will get your final solution as what I'm going to write this side. So you get negative 2, because 2 into, negative 2 into 4, you're getting negative 2, and then negative 2 into positive 2, you're getting 1, negative 1. So we say negative the root of 3. So this is the final answer. If you punch this on your calculator, you discover that it's exactly the same as what you can get after punching this in the calculator. Okay, so this is the solution for tan 105. So for these other three, I'm not going to solve them. I'll just show you how to convert them from radians to degrees because the angles are in radians. So for instance, if I want to convert this, one thing you have to understand is that pi in radians is equal to 180 in degrees. So we have pi over 12. So pi over 12 is in radians, so we put it this side. Then we're saying this is equal to, write it properly. Okay, let me just write pi. Okay, so we said pi is equal to 180. So pi over 12 is equal to x. We don't know what it is in degrees. So we can cross multiply. So when cross multiply, pi times x, we're getting pi x is equal to, then we say pi over 12 times 180. So we're going to get 180 degrees pi, everything over 12. So when you divide 12 into 180, and so when you divide 12 into 180, you can just reduce it bit by bit. So this side we have pi x is equal to, so I think 12 can go into 18 once, and then remember, we remember there's a remainder 6. Yeah, so that 6 we add it to 0, then 12 into 60, that is I think about 5. Yeah, it should be 5. So we have a pi, we still have pi this side. So we can divide everything by pi, this and that goes. So even that. So the value of x is simply just equal to 15 degrees. So cos pi over 12 is simply just equal to cos 15 degrees. So this is what you use now. You find two special angles that can add up to 15 degrees. So those two special angles are the ones that you use now using the cosine compound angle formula. Do we have any questions before we proceed to the next question? Okay, I think everything is clear. So I'm ending the meeting now. Once I end the meeting, you should quickly join using the same link. The same link I sent is the one that you used to join.